Right. So, good afternoon, everybody. Welcome. This is our group, Nishi, Karishma, Peggy. We have the following terms to define. One, algorithm. So an algorithm, we said, was a number of steps that one had to follow in order to achieve an outcome. So if you have to take an example of you preparing a dish at home, the recipe calls for, you have to put the oil, warm the oil, the onions, fry the onions, then you put the spices. Making salad, clean the carrots, then you grate the carrots, you rinse the tomatoes, you rinse the lettuce, and you go for it. Notice my word, clean carrots, clean data. The next word we looked at, it's also an iterative process. So if you are cooking a meal and you notice that there's not enough salt, you take your taste. Oh, I need more salt, so I'll put in another teaspoon of salt. That's the steps that's involved. So with data analytics, we also have a number of steps to do. We can't go and analyze data if we don't have the data, right? The next word we spoke about was analytics. We want to make sense of this data. What is going on with our data that we've collected? And we used, and our example was the age analysis. The age analysis, we said, DUT, if we notice that the number of staff are in the 55 to 60-year-old bracket, and we have 3,000 staff, and we notice that, listen, there's 2,000 staff in that bracket, then there's something not right with our human capital services. They need to start employing staff in the 25, 30, so that we have a succession plan. We looked at the next word was anomaly detection. And we said, listen, are there software out there that can pick up detection in data that's not consistent? And we thought of examples to explain this. And we said, okay, so Charity works at the research office and she deals with conference funding. If she notices that there's lots of conference applications for a particular person that's constantly going to Europe, then Charity must look into that and say, hey, there's something not right about this candidate applying for conference funding. Alternatively, people who are in the human capital services, and they notice that there's leave applications coming in all the time for a particular person who on the week following the 20th of every month, that Monday, he is definitely absent. There's something up there, so we pick up that anomaly is he's having a great time enjoying his salary, and on Monday he's having it and can't come to work. We looked at another one about petty cash examples, and you notice that, listen, if there's a spreadsheet of 1,000, 1,200, 5,000, and there's petty cash being taken from a particular department on a particular day of the month, there's something not right. You notice it's under 500, it's supposed to be 499. That software can pick it up, and what software was audit command language. The next term we looked at was machine learning. Machine learning, we found on Google that it's a subset of artificial intelligence. So according to the literature, it says, we haven't reached the stage of this Terminator, Arnold Schwarzenegger, where machines or robots have earned the ability to be conscientious beings, determine right from wrong, morally correct, and whether the person is guilty or not guilty, and they don't have the empathy that we have. The machine learning that we are talking about is where we take our data, we punch in the data, and the computer or the software goes and determines what's in inverted commas sense of that data with a particular accuracy level. So you can say, if I punch in all these characteristics of a particular person with a particular age or a particular gender, then there's more likelihood or 80% likelihood that this person could be suffering from this disease or that, whatever it is. The next term we looked at was modeling. Modeling is where programs that recognize the patterns and we ultimately are able to make a decision. So given the data that we have, the computer or the program that we use will make a prediction. And thereafter, we will take that model that we created and we will implement it in another set of data. And again, if the model that we use and we created was set on data that's erroneous. So let's say, for instance, we take an example of our data only being, how's my time? Am I okay?
Well,
All right, so let's say, for instance, our data is only candidates from Africa, Nigeria, and Kenya, and they have a particular body type and makeup. And now we take this model that we created for the people in Africa, and we now go and implement it for the people from Europe with a different set of, I'm not sure what the medical term would be, but that would affect our outcome. So that's where I'm talking about a model. And then we spoke about normalization. We want to organize the data according to certain rules and regulations. And Peggy is from ITSS, she has to capture marks. And she says, listen here, as academic staff, you should not be capturing marks above 100%, because nobody, okay, my students get 110%, but that's not the story. Or we should not be entering in marks on the software for a student that's not registered or deregistered on the system. Right? Maybe just not you in my team. Okay, so that's like talking about normalization. The next one was about prescriptive analysis. And we use the example from medical science, where we have a number of images that the computer or the software is using. Let's say, for instance, it has images of cancerous cells that are malignant or benign. And we say after 1,000 odd images, it can then determine whether the 1,001 image, based on what it knows about it, is cancerous, and can inform the surgeon, listen, we need to go and cut the tumor or not. On another simpler example of this descriptive analysis, we want to, next one, in comparison with predictive analysis, we want to use the following example and work with me. Feature number 1, 4 legs, 2 eyes, 2 ears, a tail. Feature number 2, 4 legs, eyes, 2 eyes, a tail. Feature number 3, feature number 4, I'm going to go on with that. And then I tell you feature number 5 or feature number 6 makes a sound, whoa, whoa. A dog, right? But if I hadn't mentioned to you that astounding characteristic with sound, you would not have known. Like my colleague had mentioned, you could have said it was a horse, a cat, a rat. All of them have 4 legs, all of them have tails, all of them have, right? So that's the definition of that. The other thing we spoke about was forecasting based on the data that we have available to us. And we can make a decision on that. So let's say, for instance, if the temperature is consistently 35, 36, 37 degrees, you'll notice shelf speed gets shorter as well as the distance. Oh, you didn't get that. Okay. Right. So that was it. The other thing we spoke about was structured data. Now, whenever we're collecting data, we want to be able to analyze the data. And we realize that if we are collecting the word male and female, like we all did in terms of gender, and we have to store that on a spreadsheet, because that's what structured data is all about. It says it has rows and columns, uniform data. And we want to now be able to capture whether it's male or female. If we have to take the word M-A-L-E, you're going to get capital M-A-L-E, or M capital A, capital L, capital E, capital. Or same thing with female. Or maybe you'll just say capital M and capital F or so. A way around it is to structure this data is to now assign a numerical value, because that's what structured data is all about. So we're going to say for male, 1, because males are number 1. Whoa. And I'm following up from my colleague out there, right? And female, we're going to say female will be 0. So then we're structuring our data, and then we can put it very neatly into a column where gender would be 1, 1, 1, 0, 1, 0, 1. And we can count the number of ones, count the number of zeros to state that there are so many number of males, so many number of females. And the last one we spoke about was regression analysis. And then we found that there has to be some relationship between variables. And again, from our little knowledge of research, we say there's an independent variable and there's a dependent variable. And we have to look at what a picture or analysis we can come up with from the data based on those variables. That was very briefly what our group, my group of Nishi, Peggy, and thank you very much.
Only one comment per day.
Yes.
We're going to attend the diversity course afterwards. Okay. All right. Who's next? You guys go next?
Thank you. Thank you, thank you.
Yeah.